And we're live from downtown Mill Bay. I could be brown, I could be blue, I could be violet sky. Okay, to go over it from last day, so we have 4 quantum numbers that are represented as 4 different variables. N, L, M, and S. Their letters and what they stand for, honestly, are... It's not that they're not important, it's that it won't help you. N just stands for the energy level, and it's very similar to when we did the Bohr model, first energy level, second energy, third energy. It's actually true. They are the same thing. It's just that Bohr didn't realize that some things were different. But this is the first energy level, this is the second energy level, and if you squint really hard, this is the third energy level. We're going to go through what these mean. We're going to start with N. N then is 1, 2, and 3. And that, for that reason, it's known as the principal quantum number. And I'll put that down and pull this out to the side. Oh, where did it go? There it is. Nope, this way. There we go. Okay. So far, quantum chemistry should feel okay, even though we're doing quantum. It's just energy levels, 1, 2, and 3. Well, good. Is anybody not finished? Okay. We can calculate the number of allowed electrons in each energy level. It's given by the formula 2n squared. So, class dojo. Jonah. 4n is equal to 1. What is the max number of electrons? 2, 1 squared equals 2. Excellent. Well done. Nope, fair enough. 4n is equal to 2. I will ask Brooklyn. Louder? What's 2 squared? Sorry? That's 4 times 2? 8. Excellent. 4n is equal to 3. Oh, Simon's not here. Kaylee. Oh, okay, I'll relax. Going too fast, going too fast. $18. 3 times 3 is 9. 2 times 9 is 18. Now, we have learned the Bohr model in grade 10 when we didn't mention quantum chemistry. We teach you 288, and then that is in fact wrong. And I kind of mentioned that here and there. But we're going to see why it works anyway. And so the amount that fit in each energy level is 2, 8, 18. The third energy level that has 8 is just that it leaves the 10 until later. And so it just pops up in the next level, but it's really in the third energy level. But we'll see how that works out. But we can see it's already corresponding fairly similar to Bohr with just the straight up 288 planets around a sun type model. Now, this is for looking at energy level N. So in each one of these cases, we're talking about the energy level N. For the next case, will anybody object if I move to the next point? We're going to consider L. Quantum number L. Let's switch up colors. Each energy level may have sublevels. Question, dude? It's number L. L's more of a, I mean, it's a holder for a number because it's a variable. It's like X is a number. It's just you don't know what that number is. The number of sublevels equals N. I don't know why I put it in quotes. That's probably silly. I should have underlined it to emphasize it. Therefore, for N is equal to 1, hugely important then question, how many sublevels are there? Sabina. It is equal to N. It's just 1. So at this point, L is equal to 0. Not the amount. The first energy level L is 0. In the same way that everybody labels apartment buildings incorrectly. The ground floor is level 0. And then you have to move up to 1. Doesn't make any sense. You're not on the first floor if you're just on the ground, because you're not on a floor, you're just on the ground. You have to go up to 1. The basement and floors down should technically be like -1, -2. It's a number line. The basement can't be 0. That makes no sense. So the first label is 0. That is an energy level. So it's not the amount of energy levels. The first L is 0. Also, we have given them nicknames. Or suborbital, S. So S is the nickname for L equals to 0. That is the S orbital. Now it probably feels a little bit like hieroglyphics before they found the Rosetta Stone. However, we have the Rosetta Stone. We're just labeling things. So these are just arbitrary labels in many ways. Yes. Right. L is equal to 0, and we nicknamed it S. Yeah, sure. So L can be multiple things. S is when it's 0. So the 0 is S. It might help. It might help if I do this. For N is equal to 2, then L, how many sublevels are there when N is equal to 2? Valerie. Pardon? No, there's no, because over here, how many sublevels are there? No. That is a sublevel. The number of sublevels equal N. What does N equal here? 1. So that is 1 sublevel. Zero there is not 0 sublevels. That's a sublevel, level 0. How many sublevels if N is equal to 2? Valerie? Say it again. Did you say 8? That's a lot. The number of sublevels equals N. What does N equal? 2. So how many sublevels are there? Sorry? Louder? 2? Yes. Sorry, I your voice got quieter, I think, because, it. So N is equal to 2. There are 2 sublevels. There is 0 and 1. 2 sublevels. And these also are suborbitals S and P. Those ones are S. Number 1 has the nickname of P. Do you feel like you're doing quantum chemistry now? Because if you went and explained this to someone else, they would have no idea what you're talking about. But I promise you, the labeling is the toughest part. The actual quantum chemistry is super easy. In high school, we're not going to calculate anything. It's just labeling. So for N is equal to 3, how many sublevels do we have, Francois? We have 3 sublevels. 0, 1, and 2. Or suborbitals S, P, and does anybody know what the last one is? Yes? D! Yeah, it's a D. Oh, hold it. Can you see that? That seems to go off the edge of the board there. Is that better? And quantum physicists. Yeah, apparently, I have assigned a question on this, and I did not mean to. You should have no questions that have these yet, because you haven't done it yet. So if you got that far, hold back. Don't do it yet. Okay. And we can continue on, of course, for N is equal to 4. And this is about the last time you'll ever see it. L is equal to Davis. Excellent. And so now we have four sublevels. Oops. And or S, P, D, or F. 0 is S, 1 is P, 2 is D, and 3 is F. Yes. Oh, because if we went to n is equal to 5, I mean I'm not continuing, because at n is equal to 5, we're talking about elements that don't exist on our periodic table. We're into elements that fall apart. So once we get to the F orbitals, we have gone beyond the inner transition metals, and we are off the periodic table. Yeah. So we only go this far because we only need to go that far. Yeah. And you could keep adding elements until you had an well, actually, it depends. Do you a nucleus is a core of protons and neutrons. Do you believe that a nucleus that consisted of only neutrons is a nucleus? Or are you prejudiced and think there must be protons? There won't be any electrons. It's just neutrons. Well, they have made what they called neutronium, which is like, I think it was 2 or 3 neutrons just together, and that's all it was. They called it like a new type of element. And that's what a neutron star is. It's just neutrons. So you can get that big. But for stable elements, I mean, theoretically, you could keep adding until you got large enough that it collapses into its own black hole, which is a little larger than a neutron star. So swap out some of those neutrons for protons. Theoretically, you could have a massive element, moles worth of things, because that's how many like individual protons and neutrons you would have. Massive. But they do fall apart, so we don't get there. Any questions thus far? It can. So let's add on, because that's a useful one. What's 4 then? Mimi? 32. 2. And that's the last one. Oops, I shouldn't do that. And that's why you see in the Bohr model, it goes 2, 8, 8, 18, 18, 32. Now, although the 8 and the 18, they're spread out a little bit, they happen twice. And that happens for reasons that we'll get into later. What? Stop that. It is actually, these are familiar numbers. The 2, 8, 8, 18, 18, 32 is a familiar thing from Bohr. So we're on the right track. It is for some reason, quantum thinks that these jump per energy level. So we do have to work out why is that happening. We haven't done that yet. And then here we start labeling things, because now these orbitals have shape. S, or L, is equal to 0. In an atom, here's our nucleus. And you don't have to write this down. I'm just showing you. This looks like a sphere. If an atom has an s orbital, that means its bonds can have any point of contact around it, and it will have implications for how it reacts. If you have a p orbital, L is equal to 1, then there are now 3 of them, and they look like this. Well, they look a little fatter than that, actually. Two electrons fit in each type of orbital. So 2 fit in there, 2 fit in there, 2 fit in there. All of those are p orbitals. We get into d orbitals, they look like this. Except when they don't, because sometimes they look like this. Yeah. It does look like a flower. And that's just one of the d orbitals, because some of the d orbitals look like that, which is different, and some of them look like this, and some of them actually swing out towards you. So there's 4 different variations of this one, and then that one. Each one of them holds 2 electrons. And then, like, F orbitals are like crazy sauce. They're like, and that's like an F orbital. So they all have different shapes, but I'm not asking you to write this down. This is implications for bonding. This orbital will tend to bond in those 2 locations. D orbitals can bond in more locations. This can bond in 2 locations plus fit any bonding around its ring anywhere it wants to. So these orbitals have actual definitive shapes. So you can think of S as standing for sphere. Is that good? Are you feeling like you know a little bit about quantum chemistry but still slightly confused? That's exactly where I want you. We can get ready for the quiz now. Now, Hebdens can come in while I'm getting the quiz ready. And where are they? There are the... Oops. Thank you. What's that one doing there? Now these data booklets should be fresh and clean. Oh. If you have any writing in them, please, and it's distracting to you, give them back, exchange them for a fresh one. The writing is just because we reuse these. No, take one, pass one back. But also, you are going to get a fresh one. This is yours. You should put that in your book. Okay? Pardon? You were allowed to write in them, yeah. And we just hand them in after and we reuse them. Oh, excellent. Did I give you 4 or something? Okay. 1, 2, 3. Now, I'll go through these during the class, but you should be aware that as I go through, one of the things I'm checking for is, were you up to date at the moment the quiz started, and had you previously done your homework? Or did you, cram the night before and you didn't have a chance to finish your Hebden? So, yeah, you handed in your essay. It was poor planning, but if you are up to date to today, then that is fine. Yeah. Okay. Now, if you didn't get it in today, just get it in for next day. But that is an expectation, because if you're doing the practice work after the course, quiz, or test has happened, that's not efficient. Oh, laptop away? Oh, and a reminder, of course, put laptops in your bag. You should have a you should have a scientific, not a graphing calculator. It may also be useful for you to have a ruler. Oh, my goodness. You are the only exception to this rule, only for today, because you had no way of knowing, and it won't help you. Yes. Now for yours, yep, take one, pass it back. I'm going to alter yours, because I'm just curious. Oh, really? Oh, you just joined for fun. Well, that's excellent. Okay. We're going to make this pure water. It'll be at 0 degrees and 100 degrees Celsius. Contaminated with salt. So it's just salt water. You may not be able to do that at all because that's a specific thing, but if you could graph the phases and what it goes, so put temperature here, time there, and then what happens to the temperature over water over time. This you might be able to do if you've done some previous chemistry. Oh, really? Excellent. Okay. And then possibly, no, that maybe not. That probably not. I thought now if you're looking at it like I can't do a single thing, then what you could do is you could pull out your Hebden, start at the very beginning, and start like catching up. That'd be fine. Yeah, that's exactly And you do it all the Hebden here, no notes go in there. Oh, hold it. Why are you two talking? Hold it. Kaylee, can you hand the quizzes behind you? Okay, good. Anybody not have a quiz? I'll be right there. I would like you to do the minimum. Okay, so for each section, I just assign a few questions. And then in that section, if you're like, I need to do more, do more. But yours will be look at those questions, and then go to the notes and see if you can do them in conjunction with understanding the material. They are. I just posted them the other day. Yep, yep. So if you're like, this is complete. Oh, thank you. You should draw the best graph you can.